Welcome to another lecture from Data Formats. Today we are going to talk about key value formats, which are used in two main use cases. The first one is key value databases, and this is out of the scope of this course. But the other use case is configuration of software. So when you configure a software, you have multiple options of how to do that. If you can be satisfied with a simple configuration, you may use just command line arguments for that, where you can specify a few attributes and basically that's it. Alternatively, you can use environment variables, where again those few simple arguments can be passed to your software. If this is not enough, if the configuration gets a bit more complex, you can also go all the way to the data formats that we already talked about. And for example, you can see an example from Apache Genafuseki, which is a triple store. And if you want to configure it, you can use an RDF turtle configuration file for that. Another example that we have here is from Apache Solr, which is a search index. And if you want to configure that one, you will use an XML configuration file. Example of that you can see in the right-hand side of the slide. And another example can be configuration using JSON. Here we have an example from Drupal, which is a content management system. And if you want to configure it, you will use JSON for that. But these formats are quite complex and not necessary for many use cases that you will come across. But the question is, okay, if command line arguments are too simple and configuration files in those data formats are too complex, are there any alternatives? And there are, and today we will talk about those. And we'll start with something very, very simple, and that's a properties file. A properties file comes from Java world. It is Java specific, and it is very simple. It is encoded in ISO 8859-1, also known as Latin 1, ANSI, or US ASCII. Basically, you can only use US ASCII characters, and what the configuration file offers is you can have comments and you can have key value pairs, and that is it. It corresponds to a hash table, and this, the key value pairs are often called a hash table because in a hash table what you can do is you use a key and you get a value, and that's it. So that's why sometimes key value pair based files are called also hash tables. Another use case of a properties file, which is actually not only Java based, is for storage of localization or translation strings of software. So imagine you are coding a software with a user interface and you want the user interface to be multilingual. So one way of achieving that is that you take all the strings that you use in the software, you list them in a properties file, and you'll have one properties file per language. And as you will switch the properties files, you will switch the language of the user interface because all the strings in the user interface will be defined in that properties file. So this is also done also in non-Java projects, and this is what you can come across, or when you can come across a properties file. One interesting note is that the properties file specification in Java also specifies its XML version, which is very simple XML format. So you have your properties root element. There is space for one comment, and then there is a list of entry XML elements where each has a key attribute listing the key and a value of the element contains the value assigned to that key, and that is it. But we already know how to work with XML, so now we will focus on what we can do with the properties file. And we'll have an example like this, which also showcases all the features that a properties file has. So comments can start with hashes or with exclamation marks. So there are two options for comments. And then we have our key value pairs. So a key and a value can be separated by a space, a colon, a equal sign, or a combination of white space and equal sign. So those are the first four examples. And then the fifth example is actually the same. It is a key value pair. There is a dot used, which suggests to people that there is a structure. But in a properties file, this is really just a visual effect. Technically, this is still a string which just happens to contain a dot, but it is not it does not have a special functionality. It is just a string containing a dot and used as a key. So value 5 here is just assigned to a key that accidentally contains a dot. And then there is a multi-line string where actually the new lines are escaped by slashes. So this is a string encoded as a multi-line string. But actually, when you load it into your software, it will be represented as a single line of text. Let's now have a look at how this simple properties file can be handled in code. So I will demonstrate this on Java code, but we won't use any advanced Java things. So I am quite confident that all of you can read this code just fine. So first we will open the properties file and load it into a object of a class properties, which is there in Java to store the configuration from a properties file. Once the properties file is loaded, we can then access the individual values by their keys and the getProperty method. So we'll get each key from each line of the properties file, and we will print it in the console, and that's it. So as we can see, we'll print value 1, 2, 3, 4, and 5, and then the multi-line value is actually printed as a single line of text because the new line there is escaped. And that's it. That's what you can do with a properties file. Now let's take a look at something you probably already have seen somewhere in your file system if you ever used a Windows-based PC. And that's an INI file. So INI stands for initialization, and it is used in Windows-based, but not only Windows-based, but mainly Windows-based PCs to store configuration. But even that is no longer necessarily true because an INI file actually originates from MS-DOS, which is a predecessor to the Windows operating system, and there really the configuration was stored in those INI files. In Windows there is this Windows registry system which serves as a primary storage of configuration in Windows, and it gradually replaced the INI files, but not entirely, and sometimes you will come across an INI file in Windows. For instance, in special folders such as desktop or documents or pictures or downloads, where you will have a hidden desktop.ini file and it will contain something like what you can see in the upper right example. It is not really clear at first glance what this means, but it actually specifies the icon that folder should have in Windows Explorer when you look at it. So it specifies that the desktop folder icon should look like desktop, and the downloads folder icon should look like downloads. So this is what the desktop INI file contains. But this is actually not really interesting use case. A more interesting use case is, and this is not Windows based or Windows specific, for instance in PHP, which is the preprocessor used to dynamically generate websites or web pages, and there its configuration is stored in an INI file called php.ini, and you will find this file also in a Linux-based environment. So these configuration files are human readable, and they are very simple to parse, also encoded in Latin 1, so no support for Unicode here. The INI file structure is not really standardized because it is just defined originally by Microsoft, and it is just used. And because it's not very complex, there are only sections, comments, and key value pairs. There is no official standard or specification. The INI file can be viewed as a two-level hash table, because the first level consists of the section names, and when you use the section name, you will get the value which is actually the key value hash table in that section. So that's why it can be viewed as a two-level hash table. Now let's take a look at how you can actually load such an INI file, and the example here is based on Windows API. And the example here is in the C language, and it demonstrates how a string and an integer can be loaded from an INI file. The method in Windows API that is used for this is called getPrivateProfile, and it has variants based on which data type you want to get from the file. There are two examples here in the slide. The first one actually loads a string. So the method here gets the section name, the key name, and then a default value, which is used in case that the value is not found in the INI file. And then, because we are loading strings in C, we need to provide a pointer to a buffer and the size of the buffer, so that we don't cause buffer overflow. And then the last argument is the file name of the INI file. When we want to get integers from the INI file in Windows, the situation is a bit simpler, because we don't have to use buffers. We just use the return value of the method getPrivateProfileInt, and that's the value from the DB settings INI file that you can see on the right hand side of the slide. So these are INI files. Still quite simple. They only support the sections in addition to the key value pairs. Now, if you want to get more complex, we will talk about TOML. TOML stands for Tom's Obvious Minimal Language. And the interesting thing about TOML is it extends on the INI file syntax, which can be seen from the example in the slide. But its specification actually in its 1.0 version was released in 2021. And its motto is a config file format for humans. This is quite interesting because so far every configuration file format states that it is meant for humans and that it is human readable and writable and easily parsed. So the same goes for TOML. It also maps to a hash table, but this time the implementation of TOML, the libraries for individual programming languages which are available, translate data types from TOML into native data types in that particular programming language, which means that the values are no longer just strings as in INI files and properties files. In TOML, those values actually have data types. And also TOML supports or is encoded. The TOML file is encoded using Unicode, so there is no longer a need for escaping regular Unicode strings. TOML has also its own media type, application/TOML, and a typically used file extension, .toml. Now, in the slide you can see a complete TOML example, but I will introduce you to TOML step by step. And we'll start with comments. So comments in TOML start with hashes, and that's it. So those are comments, and then we'll talk about key value pairs, which are quite essential for a key value based format. And here in TOML, there are actually 3 types of keys, which is interesting. The first is called a bearer key. It can only use a subset of strings, of characters, which are safe to be used as keys. But if you limit yourself, or if you limit your key to this subset of characters, you do not have to quote the key. You can use it just as it is. If you cannot limit yourself to this safe subset of characters and you want to use spaces or other special characters in your keys, you need to use the quoted key, surrounded in double quotes. And then there is a third type of a key, which is called a dotted key. And this one has a special function, which we will come back to later in this talk. Okay, so those were keys. Let's now move to the value side of the key value pair, and we'll talk about strings. In TOML, there are 4 basic string types. There is the basic string in double quotes, which can contain escape sequences for special characters, such as double quotes themselves, but it cannot contain new lines. So this is a basic string. If you want to use new lines in your string, you can use a triple double quote delimiter for that, and then the new lines are preserved in the value. In this case, however, the new lines are all escaped using a slash, which means that the resulting string is actually not a multi-line string, it is a single line string. Another type of string is a literal string, which is used with single quotes, and this one doesn't allow any escaping, which also means that you can use the special characters just as they are, except for new lines and single quotes. And the combination of a literal string and a multi-line string is a multi-line literal string, and here all the white spaces are preserved except the first one, because it is expected that you will start a multi-line string with a new line right after the 3 single quotes. So the first new line after the 3 single quotes is actually ignored, but then all the white space is preserved up until the final triple single quote. So those were strings. TOML has support for numbers, and those are integers, those decimal integers we are used to. But besides those, it has support for hexadecimal numbers, starting with the 0x prefix, octal numbers, starting with the 0O prefix, and binary numbers, starting with the 0B prefix. There is also support for fractional numbers with the decimal dot, and exponential numbers with lowercase or uppercase e for the exponent, and a combination of those. There is a special feature in TOML, and that is support for separators in numbers. So if you need to separate or want to separate your thousands and millions and billions so that the numbers are more human readable, and this also applies to the decimal part of the number, you can use the underscore separator here. So the underscore separator is present in the TOML file, but when you load the number into your native data type in your programming language, those separators will of course get ignored. And then there is support for infinities, so positive and negative infinity, and a special not a number, which basically results from some errors in mathematics, such as division by 0 and so on. So many programming languages actually accept not a number as a special value of their number data type. So there is a support for that in TOML. Besides numbers, there is support for dates and times. The syntax for dates and times here is quite standard. It is the same that you know from XML schema, RDF, JSON, and CSV. It is based on an ISO standard. But there is a difference in terminology in TOML, because TOML distinguishes between offset datetime, which includes the time zone offset, and local datetime, which does not include the time zone offset. So that's a difference in terminology, offset datetime and local datetime. And of course, there is support for just the date without the time and just the time without the date. In those cases, those are the local date and local time. There is support for booleans, both the true and the false values, and those are all the simple data types supported in TOML. Now TOML supports arrays, and those arrays may remind you of JSON arrays. An array can be an array of individual values. It can be mixed. It can contain other arrays. It can contain also values of just a single kind, like integers or strings. So this is all supported in TOML. There is one feature of TOML when talking about arrays, and that is the trailing comma. So trailing comma is not supported in JSON. In JSON, for instance, when you have an array, you cannot have a trailing comma after the last item, last member of that array. In TOML, this is okay. This is supported and gets interpreted correctly. This may seem like syntactic sugar, or maybe the reverse of it, because it doesn't really look good to humans. However, it is much simpler to generate those arrays, because one doesn't have to check constantly whether the currently outputted member of the array is the last one, and therefore the comma should be omitted, or it is not the last one, and therefore the comma should be there. In TOML, you can just always include the comma, which is simpler for programmers and maybe a little bit harder to read. And now we are getting to tables. Tables called tables as in hash tables, because the TOML file corresponds to a hash table data structure. And here the syntax is similar to the syntax of the INI file sections. But what in the INI file was called a section, in TOML is called a table. So a table in square brackets has its table name. And here we have an empty table called table. Then we have table 1 containing 2 key value pairs, and table 2 also containing 2 key value pairs. There is an alternative syntax for tables in TOML called inline tables. And this may remind you of a JSON object. And this is really intended for tables that can fit a single line, so that they do not waste too much space, and so that they are more readable. But it is just an alternative syntax. It actually means the same thing. It is the same structure as what you can see on the left side of the slide. So there is a table called name, and it contains two key value pairs, first and last. Then there is a table called point, containing two key value pairs, x and y, and a table called animal, containing one key value pair with the key named name. So this is actually the same as this syntax: the table name, the table point, and the table animal. So those two are actually equivalent. And this brings us to the dotted key, the third type of TOML key that I promised I will talk about later. So now is the time. Here, the dotted key actually also generates or is an alternative syntax for a table. So if we write physical.color and physical.shape, this means that we have a physical table with the color and shape key value pairs. So these two notations again are the same. The dotted key can also be used, or the dotted key syntax can also be used in table names. And it means the same thing. There is a servers table which contains two tables, alpha and beta, and each table, alpha and beta, contains two key value pairs, IP and role. So if we were to look at this structure in JSON, this is what we would see. We would see the servers table, then we would see the alpha and beta table, and then we would see the IP and role key value pairs inside those tables. Right, so those are nested tables. And this brings us to the last feature of TOML, which are arrays of tables. An array of tables can look like this. You can distinguish that there is an array of tables by seeing the two square brackets like this. So this actually is an array called products of anonymous tables. The first table contains two key value pairs, a name and SKU. The second table is empty, and the third table contains two key value pairs, name and SKU. So those are three tables in an array called products. Another example is an inline syntax for this. So we have the array, points in this case, containing three anonymous tables, each containing x, y, and z coordinates. And this is equivalent to this syntax, where we have the points member of the array of tables and the x, y, and z key value pairs listed like this. So this was TOML, and we'll talk a little bit more about how we can process it. I will again show you a snippet from Java code, which shows how you can load a TOML file, for instance, using a TOML library for Java. First, we'll of course load the file and let the TOML library to parse the file. If there are no errors, which would be then outputted to the error output on console, we can continue with actually loading the individual key value pairs. So the first example here shows us how to load the date of birth, DOB, key value pair. And we do that by calling the getOffsetDateTime method. That's because we can see that the data type of the value is actually the offset date time. So we call the getOffsetDateTime, and the parameter is the key, and we get the value which gets printed. Then there are methods per data type. So we get a Boolean, we get an array. With the array, we then get the first item in that array. We can see that actually the arrays are zero based. So the first item, or the item number one, is actually the second item in the array. Then with the database table, we get the temp targets, which is actually an inline table syntax. So we again get a table, temp targets, and from that table we can we can get the CPU value, which is a double value. And finally, we show how to access the nested tables. So service is a nested table containing the alpha and beta tables. So we get the service table, then we get the alpha table, and from the alpha table we get the IP value using the IP key. So this is how a TOML file can be processed. It's quite straightforward. And now, where TOML is used? Well, it is used in modern web-based projects because it's quite a recent data format. And I have 3 examples for you. One is traffic, which is a cloud-based HTTP proxy, which you will use when you deploy your Kubernetes systems and so on. And an example of a TOML file configuring traffic is in the upper right side of the slide. Then there is Poetry, which is Python dependency and packaging management system. And another example can be GitLab Runner, where GitLab is the version control system that you probably know. And GitLab Runner is the continuous integration and continuous deployment system that runs on top of GitLab. And you can configure it using TOML. And an example is in the lower right hand side of the slide. So this was TOML, Tom's obvious minimal language. Another format we are going to talk about today is called YAML. YAML is an acronym for YAML and Markup language. There are a couple of versions of YAML, but the last one, the current one, is from 2009, which is version 1.2. This is quite significant because in this version, some constructs were added, ensuring that every JSON file is also a valid YAML file, which is quite important for uptake of YAML. Nevertheless, YAML has also a motto saying that it is human-friendly, supports all standard program languages, and so on. So this is similar to, for instance, TOML. It is also Unicode, human-readable, machine parsable. It is not standardized by media type. It has a standard extension YAML or YML. Depends on, again, how old that YAML file is. In the slide, there is also a link to a YAML validator, which if you ever end up working with YAML, will help you getting a valid YAML. And in the slide, you also see an example of a typical YAML file, which you will know by the indentation, basically, and the representation of lists, which is quite typical for a YAML file. But again, I will introduce YAML on a construct by construct basis so that we can get to know it slowly. So the first thing is the most typical thing in YAML, and that's a sequence, also called an array or a list, and also a comment. So comment, again, in YAML starts with a hash, and a sequence is a dash, a space, and a value in that sequence. It is an ordered sequence. So here we have a sequence or array of 4 items, which are texts. And there is also an alternative syntax, and this is again introduced for JSON compatibility, but you can use this shorter array or sequence syntax wherever a regular sequence is expected. So it is again a matter of style which array representation who uses. A new thing in YAML is document boundaries. Here you can see 3 dashes which denote document start, and also at the end of the document 3 dots which say here the document ends. This is because YAML aims at streaming also, and when you imagine a streamed file, it is important to know when a document starts and when a document ends. So when you are streaming YAML data, this might come in very useful. And also in many examples, you will see the 3 dashes as a document start. But those are optional. They do not have to be in every YAML file. However, there is a more complex usage of this. The first one, in the middle of the slide, you see 2 documents, one after another. So 3 dashes, then a document containing a sequence and 3 dots. And again, 3 dashes and at the end 3 dots. You can also omit the middle 3 dots and just separate one document from another using the 3 dashes. That's what you see on the right, the same list in 2 documents, but in the middle we have only 3 dashes saying here another document starts, and at the end there is 3 dots. So that's a new feature in YAML. Now we already saw an array and we need the support for key value pairs. So in YAML, this is called a mapping. A mapping is a set of key value pairs. It is the same as a map or a dictionary or a hash or what was called a table in TOML. So it is again the same thing. It's a sequence of key value pairs. And in YAML, the key and the value is separated by a colon and a space. Now, there is again an alternate syntax to a mapping or map or hash, which corresponds to JSON object. So a JSON object again is a hash. So this alternative sequence ensures, together with the alternative sequence for arrays, that every JSON file is also a YAML file. So a YAML file or YAML format is a superset of JSON. It adds more syntax to JSON, and every JSON is a YAML file. Now in YAML, indentation is mandatory and meaningful. So this is also in contrast to JSON or XML or RDF, where whitespace was generally ignored. So in YAML, this is meaningful, and it will render your YAML file invalid or interpreted in a wrong way if you do not follow the indentation rules. So here we have a more complex example of an employee record. On the top level, we have a sequence of 2 things, and Martin and Tabitha both are keys in that sequence, and their values are maps. So this is an array of 2 key value pairs where each value of those key value pairs is a hash, a mapping. And the mapping contains, in both cases, 3 key value pairs. The 2 are trivial, that's the name and job. And the third one, as a value, contains a sequence of programming languages. So this is a more complex YAML example. Now another feature in YAML are multi-line strings, because there are 2 types of multi-line strings. The first type includes new lines, so the value will be read exactly as you see. That's when the value starts with a pipe and a new line. The second type of a multi-line string in YAML actually folds new lines. So that's the greater than sign. So in this case, in the YAML file, the string is written as multi-line, but it is loaded as a single line text value. Again, note the indentation here, and the indentation is ignored in both cases, when you preserve the new lines or not. So this is everything you need to understand the initial example. So here we have a YAML which starts with a document start, then there is a comment, and then there are key value pairs. So it's a hash. The foods key maps to a sequence of fruits. The languages key maps to a map. where for each language you have proficiency level. And education is a multi-line string with new lines preserved. So this is good, for instance, if you want to print this multi-line string somewhere. So this is a rather synthetic example of YAML. But there is a real-world example, because one of the use cases of YAML is Ansible, which is a system developed by Red Hat for configuration management and deployment management. And this is a specific configuration file. You can see yourself at the link provided. This is what's called an Ansible playbook, and basically it describes which tasks are to be executed at which servers, and there are some configuration parameters to each task. So this is a real-world YAML example. And again, we can see an array and a map being used. Now, there is one common error in YAML, and that is that someone uses the colon character in a value, which is illegal like this, because a colon is a separator between key and value. So the value itself cannot contain a colon like this. If you want or need to represent a colon in a value in YAML, you need to surround that value with quotes, either single quotes or double quotes. And again, with double quotes, you can use escapes for tabs or new lines, whereas with single quotes, the escapes do not apply. So there you can actually easily represent backslashes and so on, but they won't count as escape sequences. Now let's take a look at how YAML can be read. Again, I will show you a snippet of Java code, and it will go similarly to how the other configuration formats were loaded. So we have our developer or employee record as our sample file, and we will load this file in Java using a Java YAML library, and then we will print those values on the console. So first, again, we will load the YAML file and represent its contents as an object model as a YAML mapping object. This is quite straightforward, I think, so we can go directly to accessing the key value pairs. So first of all, we'll access the name by specifying that we expect a string with a key name, and we'll print that name. Then we'll do the same with the job, and then the same with employed. Here, you might think about employed a little bit more, because in the file employed has the value true, which is Boolean. And we actually did not talk about YAML and data types so far. And that is because in its core, YAML does not support any data types other than string. So like this, everything is a string, and this particular YAML library actually does not support any data type interpretation, and that's why also employed is represented as a string. Strings or values in YAML are also called scalars. So scalar is a value in YAML. However, every YAML parser knows how to parse a sequence, so that's how we are parsing foods. So here we parse foods as a sequence, and then for each food in the foods, we output the food. Here you can see that each food is a YAML node. We take a look at the node as a scalar, and we take its value. Now, the languages are actually a mapping. That's why we access it using the YAML mapping method. And for the mapping, we go through all keys in that mapping, and for each key, we access the value and print the value. Right. So this is how you can process a simple YAML file, again, quite simply. So this is enough for loading most of configuration. However, this is not all that YAML supports. YAML actually supports some more complex features, and we'll take a look at those right now. So the first thing to know is that actually even a key in YAML is a YAML node, the same as a value. And that's because in YAML, we can have complex mapping keys. You can distinguish those by the question mark character in a YAML file. And basically it means that what's after the question mark before a colon is a key, and what's after the colon is a value. So here we have a key, which actually is not a simple string. It is a sequence of two values. And this sequence of two values as a key maps to a value, which in this case is a sequence of, again, strings or dates in this case. And then we have another key value pair where the key is a sequence of two things, New York Yankees and Atlanta Braves. And this maps to a sequence of dates which has 3 items. So this maps a sequence to a sequence. Like this, you can also map a mapping to a mapping, or mapping to a sequence, or sequence to a mapping. So this is one additional feature you might come across in YAML, which might be a bit surprising because this wasn't present in any of the key value formats we talked about up to now, not even JSON. Now back to the data types. As I said a moment ago, the core YAML actually doesn't support any other scalars or values than strings. This is solved by introducing something called a schema. And this schema is not what you would imagine as in JSON schema or XML schema or even RDF schema. This YAML schema is a set of so-called tags, where tags are URIs. Actually, they are URNs, or they are URIs in the tag scheme. Schemas are sets of these tags where every YAML node may be tagged by a tag, which is like a special property of a node is its tag, and the tag is a URI in the tag scheme. And schemas are sets of these tags along with the meanings of those tags and tag resolution rules, which for instance can be regular expressions, which when run on the YAML scalar or a string determine which tag should be added to that value. You'll see some examples of those in a moment. But first of all, we need to talk about the first schema that is predefined in YAML in the specification, and every YAML parser needs to know it, and it only contains 3 tags: a map, a sequence, or a string, which corresponds to the YAML nodes of a type map or mapping or hash, sequence or an array, or a string. So nothing else in the core YAML, and this is called a fail-safe schema. Now another level, an extension of the fail-safe schema is JSON schema. And this is JSON YAML schema. So do not confuse this with JSON schema as in the language for describing JSON documents. This is something else. This is a YAML schema called JSON schema. But the connection with JSON is that it defines tags which allow us to represent JSON data types in YAML. So it introduces null tag, Boolean tag, integer tag, and float tag, which are the data types used in JSON. So with this JSON schema, the YAML parser is then able to parse any JSON document. And there you can see the tag resolution rules. So null is a null. A Boolean or a value is tagged with the Boolean tag when it matches the true or false regular expression. And the value is tagged with the integer tag when it when it matches the expression in the third line there, which corresponds to an integer value. And the same goes for the float here. And the rule is that the tag that matches first with its tag resolution rule gets assigned. So this solves the problem that the integer regular expression would also match the float number, but because it matches first, the integer tag is assigned to that value. And a YAML library for a specific language may then read the tag and interpret the value as a native data type of a specific programming language. So we already talked about two schemas, a failsafe schema, which every YAML parser needs to know, and a JSON schema, which is extension, which makes every JSON schema readable by that JSON parser who understands this JSON schema. And there is another extension of a JSON schema called core schema. So this is YAML core schema. And you can see that actually there are no new tags, but there are new tag resolution rules, so the regular expressions. And those basically mean that also true with capital T is tagged as a Boolean. Both lowercase and uppercase Boolean values are tagged as Booleans. Then integers can be also octal and hexadecimal, and there is special support for infinities and not numbers. And everything else is tagged as a string. So this is the YAML core schema, extension of a JSON schema, and this is actually what is typically supported by a YAML parser or implementation. But this is still not all. YAML also has support for anchors and aliases. So an anchor is a text starting with an ampersand sign, which is what you see on the third line, where we have the center key, and the value is prefixed by ampersand origin. And then later in the document we have an alias, which is the origin text prefixed by a star. And it basically means that the value tagged with the anchor should be inserted as is where the alias is. So an interpretation of this anchor and aliases is then like this. So the map where we have a key X and Y with the values 73 and 129 is tagged by, or is denoted by an anchor origin, and then the start keys in the second and third item in the top level sequence are then referencing that anchor, which means that the same map gets inserted into those positions, which you can see that the start keys have values which are the same map as the center key on the top of the document. So this is another YAML feature, anchors and aliases. Now the YAML specification also says how a YAML file should be processed and specifies that in both directions. There are some steps, and if we go from the right to the left, which means from the actual YAML document, the document is first, as a character stream, is parsed into an event tree, where, for instance, you can see that there is an anchor and alias and so on. This event tree then gets composed into a representation where there are no longer any anchors and aliases because those are duplicated, and there you have nodes and tags and so on. And based on this node graph representation, a native data structure in a particular programming language can be constructed. And this representation then, when going into going the other direction, the dump direction, this native data structure can be represented as a YAML node graph, which can get serialized into an event tree, which then gets presented as a character stream, which gets saved into a YAML file. So this was YAML. Where is it used? Well, in various places, again in web-based projects mainly. Wherever you deal with deployment or configuration management, I already mentioned Ansible. Also, if you will deal with Docker Compose, the Docker Compose file is a YAML file, or when you'll deal with traffic, where you can choose between TOML files and YAML files. Kubernetes configuration is stored in YAML, or maybe when you document RESTful web services using the OpenAPI specification, then you are basically creating a Swagger document, which then allows people to see which methods your web service has and what it expects as arguments and so on. So this documentation of RESTful web services is also written in YAML. So YAML has its use cases. And we could go on and on with more and more configuration format alternatives. So I will just list 3 more. The human optimized config object notation, the JSON 5, which is an extension of JSON, but another extension than, or different extension than YAML, and strict YAML, which is, on the other hand, a restricted subset of YAML that is easier to parse. So like these, you would find many more formats, but those are not quite widespread as YAML, TOML, and property file and INI file. Before we finish this lecture, let me just show you a screenshot from one of the projects called Helm. There was an issue in 2016 which basically was that they wanted to deprecate TOML and start saving configuration as YAML. Okay, why not? But then they convinced the developer to actually support YAML and mark TOML as deprecated. And then after 4 years, they learned that YAML is not so good, or they didn't like it, and they wanted to switch back to TOML. And issues like these you will find in many, many web projects. It just means that there is no one right configuration language or configuration file format. All of them are used somewhere. They are transformable from one to another, and there is no clear winner. You just choose the one that has support in your chosen programming language for your project, and then one you like to read as a human, and that's it.